Eigen values and vectors.
Welcome to another episode on algebra with King Solomon and Cole. Today we are talking on eigenvalues and eigenvectors. Okay, so in this particular video, I want to build the concept and make you understand what eigenvalues and eigenvectors are and how to solve questions on them. But the second video, we are going to take 3 by 3. So this one will be like for basis, or even if children watch this video, they should be able to understand. That is basically what you are doing here. So today we are taking eigenvalues and eigenvectors. But before you can find eigenvalue of any matrix, you must make sure that that matrix given to you is a square matrix. So if you are given 2 by 2 matrix, you can find the eigenvalue. If you are given 3 by 3 vectors, a matrix, you can find eigenvalue. And when you are given 4 by 4 matrix, you can find the eigenvalue. So if it is not a square matrix, it is not possible to find eigenvalues. And to talk of the eigenvectors. So first, before you can solve the question, make sure that one, it is a square matrix. It is n by n matrix. After making sure that it is n by n matrix, to find eigenvalues, the formula is given by determinant of, let's assume, a matrix A minus lambda I should be equal to 0. So if you are finding determinant of a matrix A minus lambda I, where lambda I stands for the eigen value. So if you are talking of eigenvalues, we just want to find lambda. And I is just identity matrix. So if you know the matrix A is 2 by 2, you write I as identity matrix of 2 by 2 matrix. If it is 3 by 3, you write a 3 by 3 identity matrix. So all what I'm saying is like, hey, so now let's take example and see what I'm talking about. For example, we are given a matrix A to be 7, 3, 3, -1. This is the matrix A that you've been given. Since you've been given this matrix A, you will check, is this a square matrix? Yes. Why? Because it is 2 by 2. After knowing that it is 2 by 2, the next thing to do is to find identity of 2 by 2 matrix. So this is going to be 1, 0, 0, 1. This is the identity. So what do you need? You need lambda I. So lambda I is just multiplying lambda 2, the identity matrix, which is 1, 0, 0, 1, which is going to give us lambda 0, 0, lambda. After getting this lambda I from the formula, in order to get the eigenvalues, we must subtract lambda I from A. So when you count, you have A minus lambda I. What is it going to be? It is going to give us 7, 3, 3 minus 1 minus lambda I is given by lambda 0, 0, lambda. And this is going to give you 7 minus lambda 3, 3 minus 1 minus lambda. So that is our A minus lambda I. But after knowing A minus lambda I, is that all? No, that's not all. They said in order to get the lambda, you must find determinant. How do you find determinant of 2 by 2 matrix? So you will now understand why I said this is just the beginning. So I'm using a simple matrix. It is not always going to be 2 by 2. It can be 3 by 3, 4 by 4. But understanding this will help you understand the 3 by 3 when we get there. So now, with this, how do you find the eigenvalues? They said find determinant, and in finding the determinant, you create each 0 so that you can solve for lambda. So now let's find the determinant. In finding determinant of this matrix A, B, C, D, and if this matrix is B, the determinant of B is just going to be multiplying the diagonal like this. So you get AP minus BC. That's how to find determinant. So that is what we are going to do here. So this is our A and this is our B. You multiply. So determinant of A is determinant of A minus lambda I is going to give us 7 minus lambda minus 1 minus lambda. Then 3 is minus 9. This is the determinant. You get 7 1 7. 7 times lambda minus 7 lambda. Minus lambda times 1, you get plus lambda. Minus lambda times lambda, you get plus lambda squared minus 9. What are you going to get? You are going to get lambda squared. Minus 7 plus lambda will give you minus 6 lambda. And minus 7 minus 9 will give you minus 16. And remember, they said this determinant, A minus lambda I, is equal to this. But A minus lambda I, determinant of that, should be equal to 0. So it means lambda squared minus 6 lambda minus 16 should be equal to 0. And from this one, everyone here can know when to answer, so you can solve this quadratic equation and get lambda to be 8 and lambda to be negative 2. So what we've gotten here is the eigenvalues. So now that you have the eigenvalues, what are you going to do? The next thing to do is to find eigenvectors. In order to find eigenvectors, it is just a formula way. Eigenvector, to get eigenvector, A minus lambda I times x, and x is the eigenvector that you are looking for, and this must be equal to 0. So already you have your A minus lambda to be matrix of 7 minus lambda 3 minus 1 minus lambda of the vector x. And since it is 2 by 2, the vector x is going to be x1, x2 is equal to 0. So you get 0 here. So this is what we have in order to get the eigenvector. So to get eigenvector, each of the eigenvalue, you must get eigenvector for it. So when you pick 8, you solve for the eigenvector for 8. When you pick minus 2, you solve for the eigenvector for minus 2. So you can say that for eigenvalue of 8, what are you going to get? You put 8 inside at wherever you see lambda, and you are going to get minus 1, 3. When you put 8 here, you get minus 9. Being multiplied by x1, x2, and this is equal to 0, 0. So let me clean that side, and we will solve through. So when you get to this point, in order to get x1 and x2, you have to do row echelon for this one. So in order to do row echelon, you have minus 1, 3. You augment the matrix. So you get 3 minus 9. So how do you take care of the down one? So you want the leading mark to be 1. And this one to be any other thing. But if this one is not 1, it is not possible. So let's make this one 1. So you say that row 1 will be equal to negative 1 times row 1. And also, so you have negative 1 times row 1. So you are going to get 1, negative 3, 0, 0, 3, negative 9. So now that you have this, you can go again saying that our R2 is going to be, our new R2 is going to be R2 minus 3R1. So now you multiply row 1 by 3. You multiply row 1 by 3. And you subtract it from row 2. So let's multiply by 3. So you see that after doing that process, you have 1 minus 3, 0. 0, 0, 0. Why 0, 0, 0? 3, 1, 3. If you subtract 3 from 3, 0. Minus 3 times 3 is minus 9. Minus 9 minus minus 9 is 0. So that's why we have it. So after getting to this point, you remember the leading mark is x, and the other one is x2. So it means x1 minus 3x2 is equal to 0. So we are going to get x1 is equal to 3x2. So you can say that let x2 be equal to 1. So if x2 is equal to 1, what will be x2? x1 will be 3 times 1, which is equal to what? 3. So it means our eigenvector. So eigenvector of lambda being 8 is the x1 is 3 and the x2 is 1. So this is our eigenvector. So you understand the process. You can do same for when lambda equals minus 2. I mean the eigenvalues, we have 8 and minus 2. So now you've done for 8 and the 8 you've gotten the eigenvector. Why don't we do the same for the minus 2 and see the eigenvector that we are going to get? So for minus 2, you are going to get minus 7 minus. You are going to get 7 minus 2, 3, 3, minus 1 minus minus 2, which is going to give you, and this is going to be multiplied by x1, x2. This one is for when lambda is equal to minus 2. And this one will be equal to 0, 0. So we are going to get it as augmented as 9, 3, 1, 3. And that one is going to be 0, 0. So in this, you can take any of the row to be 0. So if you want to take any of the row to be 0, your new R1 can be equal to R1 minus 3 R2. So if you have to do that, you are going to get 0, because 3 times this is 9. 9 minus 9 is 0. 3 times 1 is 3. 3 minus 3 is 0. 0, 3, 1, 0. So at the end, this is your x, this is your y. So you get 3x, 1, plus x2 is equal to 0. So you can see that x2 is equal to minus 3x1. So from this side, let me clean our eigenvalues. You can say that when x1 is equal to 1, x2 will be equal to minus 3 times 1, which is minus 3. So it means our eigenvector for minus 2 is going to be equal to 1 minus 3. So now after doing everything, our eigenvalue and vector is when it is eigenvalue is minus 2, the vector is 1 minus 3. And when eigenvalue is 8, the vector is 3, 1. So that is the end of our first lesson and the introductory class for the eigenvalues and vectors. Thank you for being with us.